Okay, welcome everyone. Today is Thursday, May 30th, and this is the Autoscaling Workstream within Working Group Serving. This is a continuation of our brainstorming discussions, where last time we were talking about warm replicas. And we'll continue talking about that today, if that sounds good. And we think about which direction to go into, and if we have time, we can move on to another topic. But what we discussed last time was largely trying to think about what signals are driving scaling today, both from like a node perspective and from a pod perspective. And so we discussed last time that we have these signals that allow us to proactively scale nodes. But in the interest of speeding up the startup time of these AI workloads, how can we maybe do this on the pod side as well?
Yeah, right. Sorry for interruption. Can you click the record meeting? Let's try to do the record to the cloud.
I thought I did that already.
Seems, yeah, so the record button is not on my side.
Really? That's strange. It says it's recording for me. Hang on.
Oh, okay, okay. Yeah, if it's on, that's good. Yeah.
Okay. Let me pause it and I'll restart it and then we'll see.
Okay, great. Now it's it's good. Yeah.
Okay. Sorry about that.
No problem.
Okay, so I don't know if there's anyone who has any thoughts before we kind of dive in. Okay, then maybe I'll kind of go over what we've been discussing in comments. So Stavros here shared some very interesting links around predictive auto scaling, which essentially tries to use historical data to give you an idea of how many replicas to turn up over time. And the idea was to mitigate the startup time by knowing in advance how many replicas you needed at a particular time, which is a very interesting concept to think about. So that's like one option here. Clayton also last time was discussing maybe using the workload startup time as a signal for scaling up. So if we know that a job takes, several minutes to turn up to start, can we feed that into the auto scaling algorithm as a way to know how far in advance we need to go and schedule that? Is there anyone here who kind of has ideas around that? Or thoughts maybe? Jackson, I don't know if you're unmuted to mention something.
Right. The startup, I think, yeah, we like to. Let me see. To me, we think there's two major problems. One is the accuracy, like the scaling accuracy, like whether the autoscaler can correctly scale the instance to the target numbers based on the current load, right? And the other one is the scaling, like the provision efficiency, how fast they can bring the node up to serve the traffic. Yeah, I think the scaling probably to us, I think the first one is more like important, and because the HPA, the feedback system, right? We like to make sure it doesn't go back and forth and adjust to the right position. So that's the most tricky part we feel in the GPU areas, and the provision efficiency is more on the model loading accelerations, and like the way we do proactive or reactive way to autoscale the workloads. So that's like more on the system optimization or like algorithm innovation side. Yeah, so that's my feeling. Yeah.
Do you kind of see then the work, like let's hypothetically think about improvements here, you would kind of target, specific improvements in either one of these kind of categories, right? Like scaling, let's say you mentioned scaling accuracy was kind of something that was more important. So are you seeing HPA like misbehaving or
So yeah, sorry. Yeah, HPA, I think HPA itself, it works fine. I think it already accumulated enough experiences, and uh, uh, I think current like the scaling policies, etc., that works fine. The key problem is the metric side. The GPU, the DCGM metric is a big problem, right? Um, that's something makes the HPA doesn't work that efficiently as usual. I think that's one problem. We're trying to solve this from like white box optimization, which means we like to dig into the inference engine to find more signals and useful metrics to use. Yeah, so that's the accuracy part. Um, and I think today, if we like to deep dive on the warm replicas, that's more probably related to the provision efficiency part. Because let's assume we still use the Kubernetes HPA, which is a reactive mode. Then we need to bring up the pod or node resources as fast as we can. But the challenge now is the pod itself. Pod itself is kind of immutable, right? If we don't like to break the concepts, in that case, how can we fastly get a get a warm replica from the warm pool? That's against the kind of the Kubernetes design. And the node level, I think there's also some I think VM is much easier to implement the wormhole, right? Like even some cloud providers like AWS, it does provide the wormhole by default. So for that cases, how can we interact with the AS to get the warm instance as far as possible? And how can we implement the a way to interact with our controllers. So like current, I think downside of the faster autoscaler is like you watch the pending pause and try to interact with the cloud providers to get the instance. But the controller, I think the workload controllers have no control. But we see a lot of requirements. They like to interact with the cloud provider directly. Let's say I like to claim some resources. If not, then I probably need to find another way to handle my workloads efficiently. So they need such signals which cannot be supported in current the CA. But Carpenter we do see some patterns like being used to address the problem I mentioned.
do you think that, yeah, I totally agree with you. Do you think though there is opportunity to maybe improve the other side of this? So like let's say we've like hyper optimized how quickly we can get an instance of VM. We're still stuck with the like startup time of the inference worker, for example. do you think there's opportunities to make that faster, or like that kind of is where this like predictive idea comes into play, right? If we know we need this in 5 minutes, then we can start spinning it up earlier or something like that.
Yeah, technically, I think we need improvement on the application side as well. Like provision efficiency, I think is kind of consists of like two parts. The first is the infrastructure side or system side, right? Like how fast a node pod can be up. And the second thing is like the application, as you said, like how fast it can load the model from the disk or from remote to GPU memory and start to work and pass the readiness, all the readiness settings, and make it exposed to the at the service level. So these that's two challenges, and the application side, I think. Yeah, people now like do a lot of optimizations to do some parallel PCIe readings and optimize the PCIe to for example like the disk to CPU memory and CPU memory to GPU memory. So that's a separate story. Um, right, but that's more on the application side and more currently more on the engine side. But I kind of feel there's an opportunity to uh, like um, uh, do some abstraction at the probably at the infrastructure layer. For let's say we can have a sidecar, right? We use the sidecar to handle all the like heavy work and make the inference engine like lightweight to load the models, and all the like the loading performance efficiencies can be optimized at the sidecar level instead. Yeah, so that's some trend I think, and we're also moving towards this way internally. Uh, yeah, yeah, that's my feeling. Yeah, we can do.
I if you don't mind, just kind of maybe explaining the sidecar approach a little bit more. You're just kind of dividing the workload over two containers. Is that what you're thinking here?
Yeah, just because the you inference engine, let's say most inference engine itself, it can load the models from remote, right? It can load from Hugging Face from somewhere else. But yeah, if they do like infra team or platform team to optimize this part, I think they can offload the work to the sidecar. So sidecar will take the role to do that, right? Yeah, so I think that's a one design pattern, but that's um, yeah, I'm not that sure if it fits all the people's use case. I do like to listen to others, like what do you think, and what's your like usage patterns?
I don't know if there's anyone else on the call that has thoughts here or maybe ideas from how they're doing it. Okay, maybe not. Feel free to add stuff to notes as well. We'd love to capture any thoughts here. So since we were discussing, warm pooling here, last time we talked about a few mechanisms to do this, right? There's this new concept of provisioning requests within Cluster Autoscaler. I believe there's a similar concept in Carpenter called node claim. I wonder if folks here have thoughts on that. Is that enough for what we're looking to do here? And how would we kind of connect these to HPA because from categorizing these signals, I could kind of see, there being a gap, but that's not kind of bridging these two things, and that's by design. But what if provisioning requests was somehow connected to HPA, for example? Curious if folks know about this, or if we have anyone from Cluster Autoscaler or Carpenter here. And if not, that's fine. I can follow up with some other folks.
I just want to say that I think there's a difference between provisioning request and node claim, right? The provisioning request is basically you're queuing up to say that these kinds of workloads are coming. Please get ready to provision them. But node claim is you have an inventory of nodes, and you want to claim them based on some metrics. It could be cost. I think that's what Carpenter focuses on.
Is there an opportunity to pivot that into, this more like proactive approach where you want to kind of lean more into like, that there's work coming? Can we proactively scale up? Is that a concept that works here or not really?
It has no notion of incoming workload request. It just looks at the current workload, and then it looks at the current inventory because Carpenter in AWS looks at the current inventory of cost of different nodes, spot instances, and all that, and then it basically redeploys on different nodes. So that's the concept of node claiming. It claims new nodes which are lower in cost for the same deployment, but has no idea that, okay, there's a background queue of workloads coming.
I can confirm this. So basically, the node claim has a list of requirements that the customer can customize maybe like the affiliate, like the toleration, the GPU they want, anything like that, memory utilization, anything. Some labels, toleration and stuff like that. And the Carpenter will just wait for any bending bot that need to be scheduled, and for some reason it didn't get scheduled, so they will spin up another one. So back to your point, they don't have anything right now to determine what is the future workload we need to spend. But I think we can discuss this with them because we already have the requirement. So we can, using some scheduling mechanism, it's like, okay, if we see this pattern, like this pod getting bending for multiple times, maybe 5 times or something like that, okay, we will spend a node and put it in a warm-up mode or something like that.
Interesting. Very interesting. Okay, so then maybe I need to go amend this table a little bit, that this node claim isn't quite in this proactive column, when in fact it should probably go here. It's more reactive because, like you said, it's watching pending pods and reacting there.
Yeah, so once we got a pod in a pending mode, and we have the the qualification, or it asked, this pod asked for our requirements, we will, or Carpenter requirements, I mean, So they will go and create a new node. And basically, the good part here in node claim, that you can span either like just a node, or like set of, like as Supan, like mentioned, we can have a pool of nodes, pool of different types. So yeah, it's, like it's just a, like plus point to take care of. It's not just this specific node and that's it. We can have like pool of nodes.
Got it. Okay. Yeah, thanks for clarifying that. So there is potentially a gap here in Carpenter for now. Like you said, there are possible workarounds. I guess you could have like balloon pods or something to reserve capacity in advance, but it generally isn't like a pattern that Carpenter, I guess, supports out of the box.
I'm not aware of things like that right now. Hopefully,
Okay.
they're working on a proposal or something, but this is not something I know about.
Gotcha.
If I could add 2 cents,
Yeah.
Carpenter and Autoscaler are 2 different implementations.
Right.
They have a bit of a overlap, and based on what's happening in upstream Autoscaler community, they're trying to figure out what exactly to do with Carpenter and Autoscaler, because both cannot coexist. One has to basically replace the other. And there is this CAPI provider for Carpenter work, which is happening, um, and that in the upstream would enable Autoscaler or even Carpenter. Um, I mean, Carpenter is currently open sourced, but it can enable um customers or users to start looking at the pricing and inventory data coming from AWS. Currently, I think that's hidden within the AWS, but in the upstream community, I think folks are trying to open that part also, so that um, anybody can start using this for even multi-cloud. And also bridge the gap between Autoscaler and Carpenter. I don't know which way it's leaning. I don't know if Autoscaler would consume Carpenter or other way around, but it's a distinct implementations. So if you choose one, you cannot choose the other.
Yeah.
Yes, it's totally two different approaches for the same problem. Um, and for like which one will win, like I think there's like I can see like both have like they have customers, and like each one like have specific set like of requirements. So some will use that, some will use the other. So like yeah, it's two different projects. About the cost, this is a good point, Soben. So for node claim, or like Carpenter, they care about the cost as well. So which is like you can choose this. We asked them to have it as an optional. Do you want it to like care about the cost, or maybe for GPU it's like no, like let's go with like this requirement and that's it. So um it's like it's a cloud provider specification right now, specs right now, so it will like be really different from one to another. And like there is two implementation now, AWS and Azure, and each cloud provider will handle the cost specs in different ways. And yes, it is open source somehow, but like it's not clear. It's not in the Carpenter core, so it's very cloud focused now.
Mhm.
Cool. Thank you for that discussion. That clears up at least a little bit of my table down here. So thank you. We're out of time already, so I think we probably need to circle back with some more experts in terms of like how to move this forward. I still think there's opportunity here to do something, whether it's like a predictive or incorporating some additional signals here. So I would love to think about this more. But like Jackson mentioned earlier, there's also some more work to think about here in terms of scaling accuracy. So I think those are maybe the topics we should keep moving on. But yeah, given we're out of time, I really appreciate everyone's participation, and watch the Slack, and hopefully we can continue these discussions. So thanks. Have a good one.
Thanks.